Okay, for this problem, we're told that displacement is given by this quadratic function, and they ask us for average velocity over certain time periods. And these you will want to use your calculator for, and I just want to show you the setup of the first one, and I'll let you go from there. But for I, you're looking for the average velocity from 1 to 3. So you want s of 3 minus s of 1 over 3 minus 1. And again, it's a calculator problem. As you can tell in 3 and 4, these numbers are getting pretty tricky to do by hand. So you just want to find the average rate of change or average velocity, and the units for each of these will be meters per second. Now, the part of the problem I wanted to spend time on was finding the instantaneous velocity when t equals 1. So we're finding the derivative at a point. So what we want is the limit as h approaches 0 of s of 1 plus h minus s of 1 all over h. So we can go ahead and use 1 instead of using x because we're looking for just a derivative at a point. So I'm going to go ahead and take s of 1 plus h, which will give me 1 plus 2 times 1 plus h plus 1 plus h quantity squared over 4 minus s of 1, which I get to be 1 plus 2 plus 1/4. And this is all going to be divided by h, and this limit will carry down there. My next step is to FOIL out everything I can in my numerator. So I'll have 1 plus 2 plus 2h plus 1/4 plus, let's see, if I have h times 1 times h times 1, that's 2h. And divided by 4 will be h over 2. And then I will have h squared over 4. And then over here, I'm subtracting out, let's see, it'll be minus 3 1/4 overall. Okay, so let's see how I can simplify this. It actually works out nicely. So my 1 and my 2 and my 1/4, that's 3 1/4 minus 3 1/4. And what you should see is, I'll bring it up here, what I have left is 2h plus 1/2 h plus 1/4 h squared. And remember, this is all divided by h. So I can simplify here. And I will, let's see, when I simplify, I can knock out this h, and one of these two h's along with that h. So my last step is actually to take the limit as h goes to 0 of 2 plus 1/2 plus 1/4 h. And my answer is going to be 2 1/2. And again, that's going to be in meters per second. That is the instantaneous velocity at t equals 1.